everyone, it's Mr. Canfield. Today we're going to be starting chapter 2, and hopefully you've gotten a copy of this packet. If you don't have one, they're on Schoology. I don't know if I'm going to be putting the nice cover sheet with it on Schoology, but everything will be available there. So here we go. The way this packet's going to work, you don't need to write your name every time because it's a packet. Instead, you can just write your name here. So I am in period 12, whatever period you're in, go for it. All right. So in our lessons, we're going to have them, we're going to see that they say LEQ at the beginning, and that's called a lesson essential question. And the big question that we're trying to answer in this first lesson is, how do I graph a line, right? And like particularly, we're going to look at something called slope-intercept form. So to write it from the book, it's what information does the slope-intercept form of a linear equation reveal about a line? Question mark. Cool. So what information does the slope-intercept form of a linear equation reveal about a line? I don't know about you, that's kind of a dense sentence. We really could just say, what does slope-intercept tell us? There's some extra words in here that we don't really need to get the meaning across. All right, but let's get started. Warm up. Elena wants to purchase a $360 iPhone. There are now two types of purchase plans for her. Plan A consists of making an initial down payment, then smaller equal-sized weekly payments. Plan B consists of making 6 equal payments over 6 weeks. Which plan would you choose? Why? So these are both examples of linear equations. We could make a linear equation to solve both of them. And if we're going to be solving, if we're going to be going over the course of 6 weeks, so we see that plan A, we're not sure how much the down payment is, but then we get to pay smaller amounts over time. Plan B, 6 equal payments over 6 weeks. Well, if it's $360, we could do 360 divided by 6 and find out that it's going to be $60 a week. So, do you want to pay $60 a week? And the way that we could write that as a linear equation is just we could write y is equal to 60x. Y being the amount that we've paid, 60 times the number of weeks. So that's one way we could look at this. Another way we could look at this is, but we don't know how much we're paying per week, but we could say that there's some initial down payment. So we're not sure how much it is. Let's say we put $100 down. If we put $100 down and we're going to pay it off in 6 weeks, well, now there's only 260 left, right? I like to pay 260. I'll divide that by 6. And 260 divided by 6, let me grab my calculator because I'm going evenly, I don't think. Yeah, so it's going to be 43 and 33 cents approximately. So we could say 43 and 33 cents per week plus our 100 initial. So these would be the same way to pay it off in 6 weeks. I picked 100 randomly. You could have picked something different. You didn't have to write anything here. I just wanted to talk about them. All right. Pardon me. I'm boring myself. No. Just kidding. Okay. All right. Example 1. What's the graph of blah? You may have seen something like this before. You may have not seen something like this before. This is an example of taking XY points, and instead of just saying, oh, I have the point 2 comma 3. Now let's just review really quick. The point 2 comma 3, that goes in alphabetical order. So it goes x comma y. And so the point 2 comma 3, which I don't think it has anything to do with this graph, I just picked those randomly. What I would do is I would go over to 2 on the x and then 1, 2, 3 up on the y. So it would be that spot right there, over 2 and up 3. The stuff that we're going to be doing today doesn't follow that order, and points don't follow the order of stuff that we're doing today. So it's important to keep those ideas separate. If we're trying to graph this is saying that instead of saying 2 comma 3, we're saying x comma 4 over 5 times x plus 2. 4 over 5 times x plus 2. It's a silly way to look at it, but it's true, right? So like I could pick any x value I want. Like if I pick the x value 5, I did that on purpose. If I pick the x value 5 and I plug it in here, well then I can say, okay, well 4 over 5 times 5 plus 2. And you can use your calculator if you're not sure how to do this, but 4 over 5 times 5, the 5's cancel and we get 4, then plus 2. So 4 plus 2 is 6. So this is 5 comma 6. I could literally plug in a ton of x values, so 5 comma 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and get that point 6. So 5 comma 6. And I could spend a long time going through and plugging in x values, getting out y values, plugging in x values, getting out y values. I'll do one more. If I plug in 0, well, let's see. Then over here, I'm going to get 4 over 5 times 0 plus 2. Well, 4 over 5 times 0, anything times 0 is 0. So 0 plus 2. Oh, 0 plus 2 is 2. So 0, 2. The thing is, it's not just these 2 points. It's literally any point on this line. The thing is, most of the points on this line, to use a technical term, are very yucky. I chose x values that give me nice y values. There are not very many x values that give us nice y values. Like if I picked 1, and I plugged in 1 here, 4 over 5 times 1 plus 2, you wind up getting 2.8. Ew. Graphing 2.8 is kind of tricky. So there's got to be a better way than just going through plugging in points, although you can always get away with plugging in a whole bunch of x values, getting y values out, and drawing your line. So what we do is we use a technique. And I think if we have these 2 points, let's see if we can draw some information out here. First, a little bit of information. Let's see. From here to here, 1, 2, 3, 4. And then from here to here, 1, 2, 3, 4, 5. Okay, so that was 4. That was 5. Do you notice anything about these numbers and our equation here? And in case you missed it, 4 was how many spaces up we went, and 5 was how many spaces to the right we went. It is not a coincidence that it's these 2 numbers. If it's a fraction, it's always going to work like that. Now, negatives get a little bit tricky, but it's always going to work like this. Let's see if we can find the 2 anywhere. I'm looking for another color. Here's another color. The 2 was that right there. The 2 is where it touched the y-axis. So all right, our next example doesn't have a graph, so I'm just going to have to graph it myself. So what this tells us, this is where we're going with this. We're going to do a lot of examples like this today. 4 over 5x plus 2. The one with the x, with the fraction, this number here is called our slope. The cool thing is that 4 and that 5, if I did it again, 1, 2, 3, 4, and then 1, 2, 3, 4, 5. I missed a little bit when I drew the line, but the line actually passes through that. And I could keep on going up 4 over 5, up 4 over 5, up 4 over 5, up 4 over 5. I could do that forever. So let's talk about this one now. This one's got some negatives on it. So the first thing, I'm going to draw my graph like this. Looks like it touches the y-axis at 5, but it has a minus on it. So it actually touches the y-axis at -5. And then it says -3/4. So if we think about this, -3/4, I'm going to put the negative, you have the option. You can say it's -3 over 4. You can say it's 3 over -4. But that is not the same as -3 over -4. Let's talk about that really quick. What's a negative divided by a positive? If you're not sure, go to your calculator, divide it out real quick. Same thing, 3 divided by -4. Divide them out. With both of these, you should get -0.75. If you do a -3 divided by a -4, that gives you a positive 0.75. So this is not the same as these two. So whenever you see a negative on a fraction, pick the top or the bottom and just slap the negative with it. So I'm going to take this first option here, this -3 over 4. So the bottom part, that 4, that's going to be 4 to the right, but the 3, how do I go up -3? You don't. You go down. So this is actually saying go down 3 and then over 4. So now we go down 3 spaces and then over 4 spaces. So the interesting thing is, you could do down 3 and over 4, or you could do this other version. So that says +3, so you go up 3, and that -4, you go to the left 4, because positive is to the right, left is to the positive is to the right, negative is to the left. That's the language I meant to use. So I could go 1, 2, 3, and then 1, 2, 3, 4. And you know, I sketched this coordinate plane, so it might not come out perfectly, but they would wind up on the same line together. Now, if I did double negative, that would not. Turns out double negative, a negative divided by a negative is a positive. So for our previous one, if I had gone -4, so if I had gone down 4, 1, 2, 3, 4, and left 5, like -5, 1, 2, 3, 4, 5, that would wind up on the same line then. Okay. So let's see if we can find the equation now from a picture. So we're trying to get y equals mx plus b. Oh yeah, by the way, this is called slope-intercept form. The reason we call it slope-intercept form, because this number here, this m, that's called slope, and b is called our y-intercept. So I kind of shied away from using the technical terminology earlier on, because I just wanted to kind of think about it and go through it. But let's look at this. Oh, they even drew it out. See how they say, oh, it goes down 3 and then goes over 4? That means it's -3 over 4, right? So we can say -3/4 x, because our slope is down 3 over 4, plus, where does it touch the y-axis? Right here. It's 0, 1. So our y-intercept is 0, 1. We just write the y-coordinate, the 1. I'm not sure if this makes sense or if this is really confusing. The best thing to do is, if you have any questions, just let me know. That's what I'm here for. All right, what about this one? Okay, well, I'm going to do the same thing I did before. I'm going to say, well, I know I'm going to have y equals mx plus b. So I got to figure out this number and I got to figure out this number. Well, let's see. You know, a lot of times finding the y-intercept is easy. Like, I usually find that first. So I see, oh, it touches here at -2. Well, I'm just going to do a plus -2. Wait, that's a silly way to write that. We can write that a better way. We'll get there. And I've got these 2 dots. I need to make sure I pick dots that are actually on the grid. The dots that are on the grid, we call these have a special name. They're called lattice points. No, not lettuce. Lattice. So we want lattice points. You just put a little bit of an accent on lettuce, and that's what it is. What do you have on your salad? Some lattice points. You just have some graph paper on your salad. All right. So so they gave me these lattice points already, but if we didn't have lattice points, we could go and look for them and find them. Like here's another one. That is not a lattice point. This is not a lattice point. It has to be at the crossings of the grid. So anyway, let's try to find the slope. Remember, the top number is how high it goes between the two. Well, 1, 2, looks like it goes up 2, and then 1, 2, 3 goes over 3. There's a phrase that we use for this, and if you know the phrase, you might be annoyed that I haven't used it yet. So I go up 2 and then over 3. There's a way to use alliteration to help ourselves here. The alliteration is rise over run. So rise on top, run on the bottom. So yeah, that's a phrase that people use. I will probably use this a lot. Our next one doesn't give us the y-intercept. Well, how the heck am I supposed to do this then?